Assignment 2 for our course is going to ask you to align standards for content and literacy using a technology lesson plan model called the NteQ model. You're going to read the enclosed files from the book, Integrating Computer Technology into the Classroom Skills for the 21st Century by Morrison and Lowther to learn a little more about this model. I've also included some examples of NteQ lessons. Note the layout of the lesson, and also that you will go a step further by including the required standards from the assignment. Depending on what subject area or content you're going to use for the lesson, that will determine what content standards you need to include. So please take a look at the ADE website to determine which standards you need. For example, if you are integrating technology into a science lesson, make sure you pull open the appropriate science frameworks or standards for whatever grade level you're working with and whatever subject area, especially if you're at the secondary level. In contrast, if you are going to integrate technology into a math lesson, then according to the same standard, or the Arkansas Department of Ed, pull open the math standards for the appropriate subject and grade level you will be working with. But don't forget to also include any technology standards from ISTE, any that you could use from the school library. If you were integrating your technology into a school library lesson, you need to find the right standards. Remember that the NteQ lesson model is a detailed outline of a lesson. It's a lengthy process. It's detailed because the model wants to ensure a successful technology-infused lesson with your students, rather than just using the technology for the sake of using technology. You will write a lesson and link national and state standards to it the same way you would be writing lessons for years, in whatever classroom area you've been in. If you make a lesson, it has to have an objective. You have to back it up or connect it to standards. The difference is, this time you're being asked to also look at those national content objectives. Arkansas Content Standards, Arkansas Library Media Frameworks, and the NETS, the National Educational Technology Standards for Students. The lesson asks you to think about your role as the LMS, Library Media Specialist, and what the classroom teacher will do in his or her role. The lesson would be taught by you in the library, so think in those terms. The lesson should teach a skill that uses technology. For example, smaller age children will need to learn to find letters on a keyboard, so perhaps their lesson would be to type their sight words for the week using the keyboard on the computer. You can show them the Shift key and how it makes the letters capitalized. Now, one problem in the past, I have had students who have just wanted to show students how to use the OPAC or how to use a database. Those are worthy lessons within a school library. They're not what the NteQ model is designed for. It really is a model that teaches students how to manipulate something using a computer, but it also needs to start with a real world problem, a real problem to those students. If you want to incorporate your technology as an iPad app or a Chromebook feature, I'm fine with that, because I think that this lesson model is conducive to those, but just make sure that you start with a real world problem. So getting started with the NteQ lesson, you need to remember that we can find any lesson or a curriculum guide that will take us as the teacher through a lesson almost immediately if we just follow the steps. But to really plan an effective lesson, it takes time. So when you're following the steps of the NteQ model that we're going to look over, know that it is a lengthy process, but proper planning on the front end will ensure that the lesson will be much better planned and executed throughout the process. So before you really get into it, you might want to think about a few things. How do you typically plan an integrated lesson that works with your students? Well, you have to know your students. You need to know what they need and where you need them to get to to be successful. If you go back to the basics of teaching and you think about why would I need objectives to help with my planning and my lesson development? How can I encourage my students to engage in the processing of information? That is key for any classroom where you are really trying to promote curiosity and create these lifelong learners, but most importantly in the school library. You might want to ask yourself, do I need to use a different lesson plan when I want my students to use computers? I think it definitely needs to be thought out ahead of time. What are you going to do before the computers? What are you going to be doing during the computers? And what are you going to do after to make sure that the entire plan is followed and that your students are learning? What's the relationship between objectives and computer functions? You might want to keep that in the back of your mind. And could you use a computer for every objective or lesson? I don't think you need to. I think eventually you need to go back to just teaching your students and using the technology appropriately, but there is sometimes a need to kind of back away from those tech devices and just really go back to the basics. So very quickly, this little snapshot. As Mr. Anista was driving to school on a crisp morning, he noticed one of the first signs of fall. The appearance of the mayoral and city council campaign signs and billboards dotting the landscape was a sure sign of fall. This year's election promised to be controversial, especially for the district around his school. The local newspaper, TV stations, radio stations were full of stories, editorials, and advertisements. The incumbent mayor and council had fought a bitter battle regarding the creation of a development near the school that resulted in the construction of a new golf. The developers had used fly ash from coal plants to create rolling hills that were capped with dirt in landscaping the course. When chemicals from the fly ash started leaching into the water supply, there was a great concern about the quality of the drinking water. Mr. Anista wondered how he could spark his 8th grade class's interest in the election process. He was particularly concerned with how they would obtain information and use the information to make informed decisions. Arriving at school, he noticed water bottle dispensers located near each water fountain, and a supply of bottled water in the teacher's lounge. There were signs above the water fountains and sinks warning not to drink the water. Mr. Anista's first period social studies class was alive with questions. Several students wanted to know why they had to drink bottled water, while others had questions about their health. As he was explaining the problems, one student living in the new development loudly proclaimed it was the mayor's fault. When asked how he knew that, the student responded that he heard his dad tell a neighbor. 2 other students mentioned signs they had seen. Mr. Anista decided to start the unit on elections 2 weeks early to capture their attention. He started by asking students how they had heard about the water problem. Most indicated they had heard their parents talking or they had seen a television advertisement. When asked if anyone had read a newspaper story or watched the news, the class fell silent. After a short discussion, the students all agreed that the election was important, that they would hold their own election on election day. When asked how they would decide to vote, the class again fell silent. With some prompting, the students began to identify sources of information and learn that some, like advertisements, are frequently biased. With growing concern and excitement, the students began to develop an interest in the election. The next day, they agreed to bring in different advertisements, editorials, and political cartoons from last week's newspapers. One student suggested that the goal was to find the truth. So that little classroom snapshot, that identifies a real-world problem, something that the students are interested in, and it's something that will impact them and they can take into their future. So what Mr. Anista could do is start going through the steps to identify effective activities that can go with this process, and they can help come up with their own ideas for this real-world problem. Which brings us up to designing an integrated lesson with the NteQ model. The amount of time devoted to lesson planning can vary depending on the available resources and the objectives. For example, it will not take as long to adapt an existing lesson plan to an integrated computer unit as it would to design a plan from scratch. So one approach is to follow a process that guides you through each step of developing your lesson plan. You might think of this problem similar to cooking. Beginning cooks need very specific directions to create a culinary delight, following every step of the instructions to a T just to create something edible. Experienced chefs, though, probably started their early careers in the same manner. However, as they gained experience, they began to modify the recipe and directions in an attempt to create a slightly different dish. Yet even these chefs always follow the basic rules. So that's what we're going to work on, is this NteQ philosophy. We're going to look at the 5 elements. You have teacher and the librarian. We're actually going to have 6. The student, the computer, the lesson, and the learning environment that's going to help you develop an integrated lesson plan that's inquiry-based and student-centered, where computers are used as a tool and the teacher and the school librarian facilitate that student learning. A few things to remember for an integrated computer lesson. It can vary in length from just an hour to a whole day, to one class period in a day, for a week, or for several weeks. The length of the lesson is going to depend on the complexity of the problem that the students are investigating, the specified instructional objectives, and the content you intend to cover during the lesson, and the capabilities of your students. As you design a lesson that integrates the use of computers, you need to consider 2 additional factors. First is the attention span of your students. How long, in minutes, hours, or days, can your students stay focused and interested in solving a problem? For example, a 3rd grade student, their lesson might last 2 to 5 days, whereas a high school geography lesson could last 2 to 3 weeks or even longer. Longer lessons aren't required just because your students have a longer attention span. You basically need to plan a lesson that's appropriate for your students and your objectives or intentions. The second factor you need to consider is you shouldn't expect to teach all of your objectives with a computer. Students should use other resources, books, newspapers, magazines, possibly journals. It could be interviews and other instructional activities, including group and or individual work. Historically, educators have viewed computers as an all-inclusive teaching machine that a student can learn from throughout the school day, but the NteQ approach views the computer as a tool rather than the teacher. It's to be used by the students to solve problems rather than to deliver instruction. For example, a pencil and paper are tools that are used extensively in almost every class. However, we wouldn't expect a student in language arts to write all period every single day. Rather, we would expect the student to use other activities such as reading, conducting research, discussing ideas in addition to their writing. Thus, each individual student doesn't need full-time access to a computer, as in the computer as a teacher model. So just because your school is one-to-one, within this lesson, think about other activities you could encourage that would take the students away from that computer so they can extend their learning beyond just using the computer to be using the computer. So for this model, if a classroom only has 1 or 2 laptop computers or desktop computers, this would actually be an advantage because you can plan for those circulations through to the technology while you have other activities going on. You can even take a group of 4 or 5 students, divide the tasks. Each one works independently on one aspect of the problem, whereas another group might all gather around that one single laptop and work on a single task. It's nice to have the option for every student to have a computer, but it's not absolutely necessary. This next paragraph talks about the novelty effect of using a computer all the time, which I think has become more prevalent since this book had been published. But with time, and I do still think that this is key, motivation stems from the computer being a useful tool. Students are motivated to use computers because the job gets done more easily and quickly than without it. Just as when we use a microwave oven because it's quicker than a traditional one, or to put it in more realistic context, computers are not used in the workplace because they're fun and something new. Rather, we use them because they're going to, technology's become that integral component of everyday operations because it's more efficient and accurate. So the NteQ model is structured to engage students in the use of computers as a tool to increase learning. So here are the 10 steps, and notice it kind of goes around in a circle, but you don't have to follow every step exactly, but it does help. Sometimes for me, if I start with the end in mind, the assessment that I want to work on, but then I can piece in the other things. So if you want to start with your objectives, specify what they are, make sure that they match the computer functions, and we'll go through this in just a minute. Then you'll specify the problem. They'll go through the research and analysis. You've got the results presentation. You have activities during the computer, activities before the computer is used, activities after. Then you're going to come up with your supporting activities, and then finally make sure that it matches with some type of assessment. It doesn't have to be a big test at the end. So if you do start with specifying your objectives, make sure that your objectives cover all the instruction for the unit or lesson, not just the information related to the computer component. A lesson can cross disciplines, either in your own classroom or as part of a team teaching project. Now remember, you are picking a content area, at least one content area, and the School Library Media Center. But for example, if you collect data in your geography or science class, you might analyze it or have, within your lesson plan, the math classes analyzing it, and then preparing the report or presentation in your literacy or English class through the library. You could do it that way. So when you get ready to create your objectives, most of us are familiar with behavioral objectives. Like, given a right triangle, the student will correctly calculate the length of the hypotenuse. That style works very well because you can identify the student outcomes, student behaviors like recall, identify, calculate, select. They're easily specified as your behavioral objectives. Just make sure if you adapt existing objectives or you create your own, that's fine. Regardless of the source, the objectives make sure that they support the goals, standards, or objectives of your district. So make sure that you are following whatever standards are used within your district. So you might want to go back into this PDF. You've got an example unit. They have 3 objectives that were created for the unit based on some specific benchmarks. So you can kind of go through and see how they break those down. So the second step is your computer function. So you want to, once you've specified those objectives, make sure that your computer functions match those objectives. So the computer functions are the tasks that the computer software can assist with or perform. So for example, any type of spreadsheet program, whether you're using Google Sheets or Excel, they can calculate the area of a triangle or a rectangle when the student enters, I guess that would be a rectangle, length and width. Any type of draw or paint programs can be used to create maps, manipulate images and photographs. Any type of word processing can help you create tables, sort a list of information in alphabetical order. So once you've defined your objectives, you need to determine if there's a match between an objective and a computer function. So some objectives such as calculate, draw, graph, sort, those are easy to match with a spreadsheet, drawing, or word processing application. Objectives describing such behaviors as plan, discriminate, evaluate, combine, infer, predict, interpret, those are going to require a little more planning and thinking to match the process with the computer function. So for example, an objective requiring the student to evaluate a story or data might use a spreadsheet or database to aid the analysis. A chart could be used to evaluate the data. A word processor could generate a report that explains the evaluation. So one approach to finding an appropriate match between your objectives and computer functions is to analyze how you would achieve the objective if you were the student. What processes would you need to perform to master the objective? So for example, would you need to collect data, perform a calculation, and then graph it? Once you've identified the process or processes required to master the objective, then you can select one or more computer functions for the student as part of the learning process. For example, to evaluate the best store to purchase a week's groceries, you might use a spreadsheet or database to help collect or organize the data. A spreadsheet to calculate the means and highest and lowest values, and a spreadsheet chart function to display the results. An objective might require only one computer function, such as calculate, draw, or sort, or it might involve several functions to arrive at the solution. So specifying the problem is our third piece in our process. The next step would be to specify the problem that the students will investigate and solve as part of the instructional process. It's critical that this problem is highly motivating and interesting, because as students strive to solve the problem, they'll develop the thinking skills and gain the knowledge specified in the objectives. So problems in an integrated lesson are based on real-world events, issues, or phenomena. The problems need to come from the student's world so the students can relate to them in a meaningful manner. By using a realistic problem, the students can more readily manipulate the data needed to solve the problem and interpret the results in terms of the original situation. So for example, imagine yourself as a student in 5th grade in Bedford, Indiana, or Greenbrier, Arkansas, or Bald Knob, Arkansas. If the textbook presents the classic time versus distance problem, one car leaving New York and one car leaving Los Angeles, and it asks the student to determine when they will meet, that problem would have little relevance to the student's world. The same problem could be written in a context where the students could relate using locations from the local area. Think about it. A lot of kids, they're probably picturing in their mind, they don't even know where Los Angeles is or New York at that point in time, but if they hear things that are relevant to them and they can look on a map and calculate those distances, hopefully, it would still have the same problem-solving approach as the original problem, but for this problem, it would make it a little more relevant to those students. So using realistic problems does require you, the teacher, to take a little bit of an additional step in the lesson design process to make it relevant. But if you think about it, consider the teaching of frequency distributions in an advanced high school math class. The problem is always presented without any context or concrete data. It's basically a calculation that students are supposed to complete with no purpose. But little do those students realize that these calculations are a central part of doing their research. So if you were to teach the topic, we could easily present these frequency distributions as a problem in a realistic context for our students. So you could construct a problem where they survey how much their fellow students make an hour a week at work, the number and types of songs on an iPod or an iPhone, the number of hours of television they watch during the week, the length of their, or frequency of their text messages. They could figure out, how many times a YouTube video is viewed. You could survey your neighbor on a topic such as how far they drive to work, their recycling practices. But then you could construct that frequency distribution to determine the mean, mode, the median, present that realistic problem where the students can relate, increases both their chances of comprehending the content and their motivation for actually completing the calculations. As with any type of information literacy process, when you define a problem, it's important to address the following 4 questions for your students. Do your students clearly understand the given problem? Do they know what they're trying to find out? Do they know what the goal is? Do they know what resources are available to solve the problem? And do they have ownership of the problem? There's several ways to ensure that students have a clear understanding of the problem they're solving. One way is to collaboratively develop the problem statement as a whole class activity by writing it on your whiteboard or smartboard or whatever board you use. The teacher can create some type of think sheet that lists the problem at the top, and it includes additional components that engage the students in defining and solving the problem, such as identifying the given, the goals, the resources. So you can establish your goals in several different ways. So you might want to go back through this PDF, this is page 10, and just kind of read back through how to navigate and get the students more involved. Student ownership of the problem is extremely important, and it's much easier to achieve in a student-centered learning environment rather than a traditional setting. And that's what this entire NteQ model is trying to develop, is those real-world problems where the students are involved and interested in finding the answers. So specifying a problem for the students typically begins by translating a problem or a topic in the textbook or curriculum into a realistic problem, as illustrated with a frequency distribution problem. You might also let your students participate in the development of the problem by asking them to suggest ideas or problems. They can provide rich context for which you can embed the problem. Once you've identified the problem, you need to check that the problem-solving process will support the achievement of your objectives. So for example, your objective for a unit might focus on the effect of climate on the types of plants grown. Your problem, however, might have the students determine how to convert a Celsius reading to Fahrenheit and to identify those countries that use the two forms of measurement. If the problem doesn't support the achievement of your objective, then it needs to be revised. Those two do not match. So after you've specified the objectives, you've determined what computer functions the students will need to perform, you've specified the problem, that's a real-world problem relevant to the students, then you need to work on step 4, research and analysis. So the fourth step is to consider the research and analysis activities your students are going to complete to solve the problem. So this decision is going to be directly related to the computer functions and to your objectives. How will students gather data? Once the data is saved in a spreadsheet or a database, what will they do with it? Similarly, how much instruction and guidance must you provide the students concerning their use of data? The following paragraphs discuss research and analysis. So in order to solve the problem, there's 3 different ways data can be used for or produced for the lesson. You can provide the students with the data. Students can generate their own data through experiments or observations, or students can search for the data either in the library or in their own classroom if they have access to the internet and other print resources. So for your younger students, you providing students with the data might be the best option, because this approach is used when the instructional time is limited, or the students have no feasible way of obtaining the data, meaning, you don't have the necessary tools and resources, or the students lack the necessary skills. So one example when you might just want to provide them with the data, if you consider a geography unit that focuses on the types of crops grown in various countries, the students need to discover the relationships between the weather and the crops. So searching for the raw data isn't really the focus of the unit. You could provide the students with the necessary information so they can concentrate on manipulating that data and discovering those relationships. Now the second method, students generating their own data, this might be when you have lab experiments, especially for a chemistry, a physics, a biology, or some social studies classes, or even a PE class. You can conduct surveys, interviews, or by observation, such as the number of students wearing seat belts when they arrive at school. 6th grade class might measure the height of a sample of boys and girls in the several grade level, and then you can study the relationships among physical growth, age, and gender. Similarly, a language arts class might count the number of times a particular grammatical structure or theme is used within a text. Now for the third method, it's where the students search for the data. Although computers create many opportunities for finding both useful and not so useful data, student data searches should not be limited only to computers, but also include printed materials and other resources from a library as appropriate. For example, if an economics class is studying organized labor, they might search the internet for historical events in the labor movement and then search in local newspapers for information on strikes or other organized labor activities within their own community. So that would be an example where students are gathering data, not necessarily their own data, but they're mining for facts. So you might want to go back through the PDF looking at how to collect data, how to use existing data, and some of the different considerations that you need to think about. Testing the data. This is one suggestion is for teachers to try a test run of their data. At this stage of your own planning cycle, you can conduct this test with actual or random data to make sure your recording form or file template, whatever it is you're using, is designed correctly. This simple test can save time and frustration later on. If there is a problem, you can fix it before the students are all trying to manipulate and work with it. And think about how you're going to provide instruction. If your students are advanced in the use of word processors, spreadsheets, databases, then they may be quite capable of entering the data with very little instruction. Now, less advanced students, your younger students, may need some step-by-step instructions on entering data in tables or forms, entering formulas, matching and searching criteria. So an alternative is to teach all the students how to do the data manipulation and then provide assistance on an individual basis as needed. So the writers of the text have observed good and bad examples of both approaches. One excellent approach, a teacher modeled the steps on a large monitor or whiteboard or whatever as the students created their own list of steps. Another extreme was another teacher who let 4 students at a time complete the process as she and the other students observed and commented. The students sitting at their desks could not see the individual monitors. There was little, if any, motivation to focus their attention or on what the teacher was doing. One of the best methods that I've found is actually doing a short screencast. I know that this one is going very long. But you might consider even putting together just a very short screencast to walk the students through the data manipulation. That way your students that need extra time, they can go back, rewind, and follow it step by step. Your faster students, they can go just, kind of watch it once and then move on with their data manipulation. Think sheets are something you can provide to help give a little extra guidance to help students organize your thinking and determine what they're going to do once they've created a graphic organizer or sorted their data or edited a video or created a chart. You can have generic think sheets that just have a variety of guiding questions such as, what's the largest, what's the smallest, what's the most common response, what's the least common response. But then you can also create your own specific think sheets that include probing questions that ask the students for implications, interpretations, generalizations, and predictions using the data. So there is that sample unit. If you want to go back into the PDF and look at page 15, I believe it had a sample unit on that went with our original examples. But the next step is planning the results presentation. Each student or group of students can prepare a written report using either a word processor, or they can go back and use just paper and pencil. You can use a desktop publishing technique, and the students can create their own books or magazines or newsletters. They can distribute their products to classmates. They can create some type of presentation using a Web 2.0 tool like Powtoons or Prezi. And then they can share their presentations with more than just the teacher. That's one of the biggest things that students complain about when they put together these presentations. Nobody but the teacher ever sees them. Or you can have your students do that digital audio or video presentation that shows the product, the end product, and it can include student-generated narration. That's one of the hardest things to write out, is that script that they need to follow. It could have student-created artwork, video clips, and other copyright-free materials, or if they have taken their own pictures or photos to put in. Students can even go back and just prepare a poster or bulletin board that displays their results. And this type, can take on a variety of formats. It could be an interactive display, a timeline, it could be computer generated, or just student created on a poster board. You could have your students publish their results on a wiki or a blog, or students can make their presentation to other students or parents. They can present their findings in a scientific format, even using an electronic slideshow or a presentation that might take the format of a lesson using printed materials or multimedia to teach to other students. You could have a poster session, web pages. They could create their own little radio show or television news show format. Any of those things would help them encourage those students to analyze their findings in a critical manner, draw appropriate conclusions, and if they know that their work is going to be viewed by others, they pay more attention than when they are just sharing it with teachers, especially if they know their peers are going to see it. A lot of times they will spend a lot more time and effort if they know mom or dad's going to see it, and those peers especially. Okay, after you've determined what your students are how they're going to present, you need to then be thinking about what your students are going to do during the computer use, before they ever get to the computer, and after they've gone to the computer. So the first thing you need to do, it's best to decide what activities are they going to do while at the computer. So once you've identified those objectives, you've got the problem that the students will be solving, you know how they're going to present, analyze and research the data, and how they're going to present it, what are they going to do while they're at the computer? So there are two factors that you need to consider. First, you need to identify the activities that the students will engage in while using the computers. And how will the students obtain information to find an answer to solve the problem? They're going to be searching for information. This is a little old. They're probably not going to be using a CD-ROM, but are they going to use the entire internet? Are they going to use specific databases, only the ones provided by the Arkansas Traveler Project? Will they have information specifically on the hard drive? Will it be all three? No, ours are typically going to be using the internet, but that's when you decide, are you going to determine which sites they go to, or can they just surf the web? So if they're going to use a database or a spreadsheet, are they going to use a template that you've created, or are they going to make their own? Depending on your objectives, you might want the students to use your template and concentrate on entering and manipulating the data, but for others, the emphasis is going to be on finding the correct data by creating the correct formula. So if students are preparing a report, drawing, or some type of graphic organizer, can they use clip art? Do they have to do original artwork? Can they incorporate digital photos? Basically, you need to identify, they're going to need clear and precise instruction on what they're doing while they are working at the computer. And the other aspect at the computer, are the students going to work individually or in groups? If they're working in groups at the computer, you need to assist the students with identifying and assigning specific roles, ensuring that all of the students have an opportunity to rotate through those different roles. When they're working in that group, one student can read the data, another can enter it, a third can check for accuracy of the entry. That might be 3 different roles you can have. But if you define the roles, that can help develop a rotation schedule so the students have a variety of experiences and it's not one person doing all of the work. So your activities before the computer. Once you've determined the activities that the students are going to work on while at the computer, and whether the kids are going to work individually or in groups, then you can focus on the activities that you need to complete before you ever get to the computer. If your students have limited access to computers because of time limitations or lack of devices in your classroom, then it's essential to design activities for the students who need to complete that they need to complete before they ever get to the computer. So if students are entering data from an experiment or survey into a spreadsheet, they can collect the data and organize it before they ever get to the computer. Or if they're writing a report, they can create an outline and gather materials before their computer time. One of the things that students can even do is brainstorm, and this is something that we did, not necessarily, as an NteQ model, but anytime we did the Big 6 for information literacy skills, is to brainstorm and plan the student search. They could identify keywords that they're going to need before they ever start searching. With proper design, students can have a much more efficient and productive use of their computer time. So on page 22, there's a really good checklist for work before using the computer. If the students need to identify their topic, one of the things that I noticed most about 6th and 7th grade, they'd have a topic assigned, but half of them didn't even write down the topic correctly. So when they got over to a computer, they were misspelling it because it was misspelled on their own paper. Then you could have them list 3 terms that they could specifically search for that information on the topic. They can list 2 other terms that mean the same as that above, so they could be thinking about those synonyms and other ways to break it down. And then they could do a checklist. What specifically are they looking for? Are they looking for pictures? Are they looking for videos? Are they looking for some type of software that's going to help them? Or are they specifically looking for articles and information on that topic? And one of the things that this text suggests is that if you walk through the steps yourself, think about through each step and identify what the student would need to complete before they use the computer. So you might find it easier to complete these steps yourself, make notes on what you did to complete the steps, and then list that information and those steps to complete before using the computer as part of your lesson plan, so you can communicate to the students with a handout, through a lecture, through a poster, whiteboard listing, anything else that the students need in order to be more successful. Okay, our 8th step is the activities after the computer use, and this to me is key. While working at a computer, the students have produced some type of results. Activities after using the computer should focus on exploring those results of the computer activity. If the students have created a concept map or brainstormed ideas or analyzed the data of an experiment or study, then they need to focus on interpreting and explaining those results. Students who've searched for information, they could actually take the time to read, paraphrase, compare, contrast, interpret the information in that information of their written report. But I think this is one of the things that we forget about. We think that their learning has ended after they've used the computer to solve their problems, but it doesn't work that way. We need to remember to go back and have those students go through and physically read through and paraphrase. I think a lot of times what we do with research on a computer, we turn the students loose, we give them 3 days to do it, but we realize partway through a lot of them get bogged down, they get sidetracked, they birdwalk, they do all kinds of things, and they never actually are successful, and then they're copying and pasting at the last minute, to get their project done, but they've never really sat and analyzed and thought about what information do I need to include and what information do I not need to include. They think just because they found it, they need to put it in whatever project they're doing. If it's a written paper, if it's a presentation, they just dump everything in there. And I'm speaking from middle school level. And when thinking about after the computer, the purpose of this part is to use the information generated from using your computer as a tool. So you could include in your think sheet, again, the handout could have either generic questions, if they're analyzing or interpreting some piece of writing, what was the writer's perspective in this news story, or they could, you could have specific questions using the graph that you created. What happened to the humidity as the temperature increased? Then they need to take those results and analyze those. So they could also have directions for how the student should read an article or a story, including steps for what they should do. Are they paraphrasing? Are they summarizing the content after they've finished that information? So this leads us into supporting activities. An NteQ lesson incorporates a variety of instructional activities. Some require the use of a computer, others rely on other forms of instruction. So after you've designed the activities that are directly related to the computer activities, then you need to focus on those supporting activities that will help students achieve the objectives. So the objectives for the lesson should cover a variety of skills and topics. Some require the use of a computer, others require different student engagement activities such as experimentation, practice, gathering information via multiple resources. Students should engage in the activities as part of the instruction for the total lesson. It's often helpful to have a variety of activities that are not dependent on completing just the computer activities, so the students can be working on them at any time. So for example, if the students are using computers to research a topic and build a graphic organizer, the supporting activities could include research and reading in several books, creating a poster, developing a presentation, and generating debate questions. So students could engage in these activities as they wait their turn to do the additional research specifically on the internet and create that graphic organizer. Similar strategies are often used when students must share limited resources such as a microscope or manipulatives if you're in a math class. You might consider the broader context and objectives rather than just focusing on the computer aspect, regardless of the student's access to the computers. Interesting lessons include a variety of instructional activities to achieve those objectives. Now, the authors also suggest you might have multiple lesson supporting activities. Basically, if you're teaching one subject, secondary level, you're doing only math or science or language arts or social studies, you could have a variety of activities going on that are independent, not sequential, but they're all going to lead to the achievement of the same objectives. So a math teacher might have one group of students working on addition of fractions, another group comparing fractions with fraction strips. You could have another table converting those fractions to decimals, and then finally one more group doing fraction additions with a calculator. And that way you could be rotating as the teacher around, and you guys know how these activities work, especially in today's classrooms, where instead of it's sage on the stage where the teacher is in front, the students are actively learning in any subject area that you walk in at this point. One thing, though, that I am most excited about is that the NteQ lesson is an excellent opportunity to create an interdisciplinary set of supporting activities. And this is where your activities require that team teaching approach, that collaborative approach that the school librarian is supposed to be doing throughout anything that we do. So for example, your students might collect data in a science class or the social studies class. They go to the math class to make the calculations. That way the math teacher is getting to follow their objectives, whatever math related activity it is, but then they could prepare the result presentation in their language arts class. That way they could be doing their writing, but it is all for a specific focus. So regardless of the supporting activities, assessment though is still the final step of the NteQ model. It's where you can do a multiple choice test, or you can go toward more authentic forms of assessment such as a portfolio, a performance, a presentation, or an experiment that the students have designed. Assessment of an integrated computer lesson typically requires more than just a paper and pencil test. So during lesson implementation, students can use a task list to guide the productivity and assist with self-reflection on the quality of work being accomplished. At the conclusion of the lesson, you might use a traditional multiple choice or short answer test to assess the student's understanding of the concepts and principles, but you could also have a rubric to assess the student portfolio, document their searches, the completion of their think sheet, and the overall presentation that they have created at the end. You might even include assessment of the group and individual work behaviors based on a journal that the teacher keeps and the librarian, and that students keep as their own personal journals. But rubrics provide a means of rating students' productivity on content standards according to predetermined performance standards. So as summarized for this very lengthy, I apologize, screencast, but hopefully it takes you through a little better understanding of the NteQ model. To summarize, effective use of computers in your classroom requires careful planning to integrate their use into a lesson. The NteQ model provides 10 steps to help you complete this lesson planning. The first 5 steps involve the planning of the content, where you specify the objectives, identify a match with the computer functions, specify the problem that the learners will seek to answer, plan how students will conduct the research and analyze the information and data, and finally, planning how they will present the results of their research. The next 3 require you to plan how your students will use the computers in the classroom. These 3 steps involve classroom management and planning for think sheets and job aids. The 9th step is the planning of supporting activities that can include support for objectives of the same unit or another unit that don't require the use of a computer. And last is planning of the assessment. The assessment of student learning when using an authentic task often requires more than just a traditional paper and pencil test. So this step will guide your planning of a rubric or other strategy to accurately assess your student achievement. So at the very end of the PDF, there are a couple of teacher technology frequently asked questions. So one of the questions, why should I create an integrated computer lesson rather than use some of the existing computer-based instructional software, that's CBI? So the authors don't really see the use of an integrated computer lesson and CBI as an either-or question. Decide instead which approach will best help your students achieve the objectives. You may decide that a CBI can help provide the scaffolding necessary to solve the problem you present in the integrated lesson. The integrated lesson allows you to create a unique inquiry-based unit that's highly relevant for your students. You can custom tailor problems to meet the curriculum standards while providing a local context of which the students can relate. You can provide this type of real-world local context, which increases the meaningfulness of the instruction. Students see a problem that's concrete, easily understandable. The integrated lesson can help construct an exciting learning environment incorporating a variety of instructional strategies rather than just focusing on the computer. As a result, book learning has as much importance as computer learning in the minds of the students. So if you've looked into your keyboarding class or whatever they call it, CBI, and you see the students mindlessly preparing a formal letter that they just have to, they take whatever the information is in their typing book, and that's what it still looks like, the same old typing book that I had 30 some years ago, and they're mindlessly just recreating because they want them to learn how to set up tabs and margins and know where a salutation goes and a closing. Think about if you instead integrated a real world problem into this concept and had the students creating that letter for a reason. The students would make those connections much more likely, and they would remember what it was they were doing rather than just this rote, uh, you know, to me, monkey see, monkey do, where they're just recreating the exact letter that's in a textbook. Okay, so the other FAQ, this does come up a lot, in the evaluations of this course, the 6353 that you guys are in right now, of this process is so long, why would I do this? So the other question, I will never be able to create enough units for next year. Is there any reason to adopt this approach? So the first year of any approach is the most difficult. So the authors wouldn't expect a teacher to develop enough material in a year to cover every lesson of instruction for every class. Teachers that they've observed start with a few units or lessons the first year and add additional new ones each year. Units and lessons that you can adapt and modify are available from other teachers on the internet. You could go to www.nteq.com. Teachers also are able to adapt many of their existing units to an integrated lesson plan by adding or rethinking the problem and the objectives. One of the best sources of ideas for lessons is your old lesson plans and your textbooks. It's often easier to adapt an existing idea to an integrated lesson plan than to generate a brand new lesson plan from scratch. So consider your objectives, your standards or benchmarks, then compare the behavior and those to the various computer functions. And teachers are often surprised at the number of possibilities they can generate for existing materials rather than just creating their own lesson every time.